Konnichiwa. Watashi no name wa Terri Norton desu. Nebraska Daigaku no Junkyoju desu. Yoroshiku onegai shimasu. Does anybody know what I said? My name in Nebraska. So I said, good afternoon. My name is Terri Norton. I am an associate professor at the University of Nebraska. It is very nice to meet you. A little bit about me. Dr. Jones has already given a preview, but just a little bit more about me. I am an associate professor within the Durham School of Architectural Engineering and Construction. I'm also a Fulbright scholar for Japan, doing research in disaster recovery and reconstruction. I hold degrees in civil engineering from Florida State University and the Florida Agricultural Mechanical University. Before coming here to Nebraska, I worked for the Aerospace Corporation doing structural dynamics research for space structures. And since being here, this year marks my 10-year anniversary of being here at the University of Nebraska. Hallmark anniversary. In my time here, I have graduated both graduate and undergraduate students in civil engineering, architectural engineering, construction engineering, and construction management. I lead the structural dynamics research group, where our focus is to investigate how dynamic loads affect civil structures. So we look at earthquakes, we look at hurricanes, we look at tsunamis, tornadoes. My research interests are in structural dynamics and control, risk assessment and vulnerability. I do energy efficiency, which is kind of out of the box, but when you get funding out of the box, you accept it. So I do some research in energy efficiency and sustainable construction, as well as disaster debris management. I'm going to start at the end of my presentation, just in case. So these publications are relevant to this work. I'm going to give you an overview of what I'm currently doing for my Fulbright research in Japan. These are some beginning publications, but as I said, this is the beginning of this work. So there'll be more implications and publications to come. And maybe if anyone's interested in this audience, you may be able to join me in that work. We could talk about that at the end. So outline of my presentation. I'm going to talk a little bit about disaster debris management, what it means for the Tohoku disaster for 2011, how we manage the debris in terms of debris processing, and then how it's being used now for reconstruction. And then I will summarize what I am talking about. So these pictures here are pictures of me visiting Japan in 2011, 90 days after the Great East Japan earthquake and tsunami. The top picture is me in front of a hospital, and it was devastated by the tsunami floodwaters. The steel structure or aluminum structure behind me is actually an awning from a gas station that was across the street. This is the same city, but another part of the city. How many of you can see this little steel frame structure here? That is the emergency management office in that city. This is Minami Sanriku, and like many of the cities along the coast during this disaster, many of the structures were washed away as long as individuals and people were washed away. Only one individual survived in that building, and he was on the top of the structure hanging onto the antenna. During my time there in 2011, I joined a team of 30 researchers from the United States, from Japan, Korea, and Taiwan. During that visit, we visited 11 of the affected areas or cities. However, we were not able to go to Fukushima because of the radiation and contamination. So this started my research in Japan in the Great East Japan earthquake in 2011. The work I'm currently doing now is to do a retrospective look at what they've done since that disaster. How are they rebuilding? How are they redeveloping their communities? What type of management process did they take to do those things? So a little bit more about the disaster. It happened in 2001. 2011. It was a magnitude 9 earthquake. It was an underwater earthquake, so it's a mega quake, being that it's a 9.0. We had over 19,000 individuals who lost their lives. Over 450,000 people were evacuated from their homes. Over 100,000 buildings were damaged, and that's not demolished structures. This was actually damage from the direct impact of the tsunami or the earthquake, and it's estimated $210 billion worth of economic damage. For this particular research, my study has been on disaster debris management because of the overwhelming amounts of debris that was generated during this disaster. With it being so many structures that were damaged, we need to figure out if we're going to resettle a community or area, what do we do with that debris? What usually happens to debris? Does anyone know?
Set it on fire.
Set it on fire, okay. Recycle. Bury it. Those are all good answers. So if you can't burn it, you can bury it. As long as it's not chemically contaminated, then you can landfill it. Or if it has viable usefulness, then we can recycle it. So for this research, I'm trying to determine if they recycle it, how are they using it? How are they recycling? Are they using it for reconstruction? And in which ways are they reusing it? Just some general information. The total amount of debris from this disaster was 28 million tons. Does anyone know how much debris was generated for Hurricane Katrina? Hurricane Katrina had 22 million tons of debris. So these two disasters are comparable. The second part of my research is being able to compare how we manage debris from different disasters, both internationally and nationally here in the United States. So I would like to do some comparative analysis about disaster debris management, about reconstruction, resettlement, and how communities, in terms of societal effects, civil engineering, environmental changes, policies that affect communities. It's an interdisciplinary problem that has many moving parts. I can't do it all by myself, so hopefully by the end of this presentation, again, some of you want to do it with me. The area that was most affected during this disaster is Miyagi Prefecture. It had 18.77 million tons of the total 28 million tons of debris. So it was the most heavily affected area. Has anyone ever seen this picture? Okay, so this is the tsunami floodwaters coming into the coast of Sendai. When I spent my time in Japan, I was at Tohoku University, and they are located in Sendai, Japan, which is north of Tokyo. And so this is the coast of Sendai when the tsunami floodwaters was coming in. Along the very top of the screen, this is the ocean. All of this area here is where the houses were along the coast. So as you can imagine, those houses were washed away. These are a couple of my pictures from different areas right after that hazard. Again, I'm focusing on disaster debris. As you can see, that disaster debris, backwards. This disaster debris is on farming areas. It's on temporary storage at the disaster site. This was a fire that was an indirect effect of the tsunami because a lot of the areas that were damaged were port communities, fishery communities. So there were some petroleum damage and fires that happened along with this disaster. Actually, one of the cities, I recently talked to one of the northern cities, and they said that their city burned for 3 days after the tsunami because of the time that the event happened. It was in the evening, and most people were cooking, and so there was open fires, gas fires because of stoves, and so that city basically burned for 3 days. This top picture here, Ishinomaki, you can see, just compared to these buildings that are standing, 2-story buildings, how high that debris pile is. So there were mountains of debris. So knowing that we have all of this debris, again, what do we do with it? How can we recycle and reuse it to improve how we recover and how the speed in which we recover? For this Fulbright, my objectives were to learn about what the Japanese has done and is currently doing in their recovery process. So I'm learning about how they manage their debris, how they are recycling, reusing it for reconstruction, what type of technologies are they using it for, and then also to develop relationships so I can continue this conversation and engagement with researchers that are there in Japan and also globally, because while there in Japan I was also able to meet researchers from Malaysia, from Singapore, from other Asian countries that deal with disasters like typhoons on a normal occurrence. And so being able to be in that setting also allows me the opportunity to network and engage with other researchers that are also in this field. So what is disaster debris management? It's basically, as it sounds, the management of debris, how you collect, how you sort, how you dispose of that debris. As I said earlier, disaster debris management is an interdisciplinary problem. So not only as an engineer will I have to deal with it, but people in the community, when you see debris after a disaster, it has a societal and sociological effect on you. Logistics and dealing with where to put it and when and who transports it and who pays for it. We have to deal with logistics. Recycling and reuse can have some environmental and medical implications. And also material characterization in terms of civil engineers. If I want to recycle and reuse this debris for reconstruction, I need to understand the material properties to know if I build something with these materials, whether it's going to be structurally stable. So, interdisciplinary. There are guides out there now to do disaster debris management. Different countries have their own guides. Here in the United States, we have the FEMA guide, which is 325. That's the most common guide that's used. However, even though we have this national guide, not every community has a disaster debris management plan. So some communities, when they think about recovering from disasters, the first thing they think about is that they want to move the debris, but it's about how do you get the assistance funding for your community so they can do the work. But in terms of the city or the county, who determines when to send the money out? When do you determine when collection should happen? How long will it take for collection to happen? How long will that affect your rebuilding efforts? So there are general plans, but for specific plans, cities have to determine as a policy that they need to have that in place. And that will aid in their recovery process. For Japan, they decided that for this disaster, in order to manage the debris, to rebuild and redevelop their communities, they decided that the whole process was going to take 10 years. The first 3 years is going to be restoration. The very first thing that needs to happen is response. That's the beginning stages of the recovery process. Response deals with debris management. We have to move debris out of the way so that we can help individuals. Then reconstruction. There may be chances to recycle and reuse debris for reconstruction. And then the last 3 years is redevelopment. To their credit, in Japan, they were able to manage the debris in the first 3 years. And now they're currently under reconstruction. They had some ideas of what to do with this debris for reconstruction. And these pictures, and this was the first conceptual design right after the disaster in 2011. They decided they were going to build coastal embankments that they were going to fill in with debris. They were going to raise roads and other as embankments, and they will fill those areas with debris. They were also going to improve their seawalls along the coastal edge, as well as redevelop their coastal forests. So that was the beginning stages of their plan for reconstruction and how to recycle and reuse debris. But to do that, they had to understand the process. So they had an idea of what they planned to do in the long run with the debris. But to break down the steps, they had to understand where to get from A to B. How do you get the debris from your site, your disaster site, to either disposal or recycle and reuse? So this flow chart basically says this is the debris management process that we're going to do as a country in Japan to manage our debris. It starts out with the waste is located at the disaster area. You're going to do some beginning separation, take it to a temporary sorting site. From there, do some more separation, some cleaning, some washing, some sifting, depending on whether it is covered heavily in salt water. They had to do some rinsing. And then from there, they'll take it to the first storage site. After going to that storage site, if it was viable for recycle and reuse, then they would send it to recycle and reuse. Otherwise, they would determine whether it was combustible or non-combustible. And depending on whether it's combustible, they would incinerate it. If it was non-combustible, then they would landfill it. If I look at Miyagi, which I said was the most affected area during this disaster, their processing methods that they decided to use, they had 100 temporary sorting or storage sites. This top one is concrete storage. Right next to it is our white products, our vehicles, and then there's some mixed waste that includes vegetative or trees. And then at the bottom are some temporary incinerators. So whatever they could burn, if it was combustible, they would burn it. If they couldn't burn it, they would shred it and sort it and try to either recycle it or landfill it. And these are the numbers for Miyagi Prefecture, and that was a prefecture that had 18.77 million tons of debris. For the recycling and reusing, in terms of us civil engineers, they decided that they want to recycle and use it for those public works projects. As I said in that beginning schematic, they want to try to use, recycle and reuse this debris for embankments and for elevating roads. And we can see here for the Miyagi Prefecture, they are recycling and reusing concrete debris as well as tsunami deposits. And that debris is being used for coastal embankments. It's being used for fishing ports projects, both concrete, and then tsunami sediments are used for temporary storage sites. They have some other projects, miscellaneous projects. Some of those include our seawalls or renovating or rehabilitating some seawalls. The bottom pictures are just storage sites. So after debris was sorted and processed, they had it sitting at a storage site until they could reuse it for reconstruction. And so that's what those bottom pictures are. If I compare Miyagi Prefecture with the other two affected prefectures, Iwate and Fukushima, I'll see that they're also recycling and reusing their debris in terms of concrete and tsunami waste. But comparatively with Miyagi Prefecture, we'll see there's a lot more projects happening in Miyagi because it was more heavily affected than Iwate and Fukushima. This plan for reconstruction talks about what they see the new Tohoku being. They're renovating their port facilities, they're renovating their roadways, their public transportation systems, their railways, their subways. They're also redeveloping communities. So the residential communities is no longer along the coast. It's being moved up to higher ground. And then they're using along the coastline either for port facilities or industrial facilities. So in that way, they protect lives because they have their population now living on higher ground for future tsunamis. But they're also coming up with tsunami mitigation measures to protect those individuals that may be working in these new industrial areas, or they're also building coastal parks. This talks a little bit about the timeline, and the font may be a little small, but the important thing here is that on this column it talks about the areas in which they're trying to rebuild or reconstruct. For you guys in transportation, you might be interested in the reconstruction of infrastructure and roads, and it says that it is 99% completed by 2012. So a year after, they had most of their roadway or arterial roads reconstructed. Why is that important?
The travel, get around.
People have to get around?
In order for you to
control where the debris go, you have to be able to have a way to move it.
So you have to be able to get from point A to point B, whether you're transporting debris, whether you're transporting materials to rebuild, whether you're transporting people to be able to help individuals. You have to have that transportation networks in place so that this can happen. So first, debris management has to happen. Part of that debris management is also reestablishing our transportation networks so that we can continue on with the recovery process. Some of the measures that they're doing in Japan to reestablish their transportation networks, they have reconstruction of public transportation systems. A couple of the JR railways, Shinkansen railways, and the Sanriku railways, those were damaged during the tsunami and earthquake. They also had some damage to the arterial roadways. And then as a mitigation measure, they decided as part of their plan for reconstruction, they're going to have elevated roadways. Let's talk a little bit about an example of how they recovered some of their transport networks. If I look at the city of Sendai, again, I said Sendai is where I spent most of my time, or where I was like headquartered at Tohoku University. In Sendai, their airport was damaged, their railway network was damaged, and also their port facilities was damaged. The picture on the left at the top is Sendai Airport after the disaster. At the bottom is Sendai Airport today, how it has been cleaned up. There were damage to the ceilings. In Sendai Airport, the front entrance is all glass. So that whole glass entranceway was damaged, so they had to renovate that glass ceiling and the window system. For the Shinkansen, anybody ever been on a bullet train? Ooh. For the Shinkansen, some of the railways were damaged, so they had to renovate those railways. Then for port facilities, they had damage along Sendai Port, which is one of the most heavily used port in Miyagi Prefecture, second to Ishinomaki Port. And so they had to do some work to clear up the damage that happened at the Sendai Port area, as well as there was some damage to railways, as I said earlier. This is damage to railway in Ishinomaki, where you can see the whole deck system of that railway bridge is gone. So they had to renovate that. In an effort to protect and prevent this type of disaster from happening again in those areas, they have come up with mitigation measures that they call tsunami dampening. And this is an example similar to the pictorial I showed at the beginning of my presentation. This is the mitigation measures that Sendai City has decided that they're going to use to prevent their city from being affected from the next great tsunami. And they're planning for a 100-year return period of a tsunami. So what they're doing, they have coastal embankments. So instead of a massive seawall, they decide to have coastal embankments. They have coastal forests, evacuation hills, elevated roads, elevated evacuation facilities, and then more elevated roads. These 4 areas that have yellow, those are areas that are being filled with disaster debris. So they're using recycled materials to do these mitigation measures. And their idea behind this tsunami dampening is that the more obstructions you have in the way of the flood waters as it comes in, what do you think will happen? It's going to slow down. So the more speed bumps you have, the slower the wave will get, right? And so that's what they're trying to do. This is me on this coastal embankment in Sendai. You can see here, actually this was last summer. So this is the ocean here. It's an embankment, and this was the coastal forest that was there during the tsunami. It looks kind of sparse, doesn't it? You can see the trees are still kind of leaning from when the water came in. So right now, this summer, they have begun replanting the trees for this coastal forest. So when I go back to Japan, I've done some tree planting. So when I go back to Japan, I can visit my babies. I have 20 trees in this area that I planted. And then I have, I think, 30 trees in another city area that I planted. So not only did I learn about what's happening, I was able to be involved and give back. So when I go back, I can say I helped with the tsunami mitigation in Sendai because I planted those trees. This is the elevated roadway. This was the plan for the elevated roadway. They are elevating these roads 6 meters above sea level. How high is 6 meters? 18 feet. So they're elevating these roadways 18 feet above what the existing roadway was. They have evacuation towers that they are also using as means of protection for individuals trying to escape floodwaters. And then this is the Sendai Tobu Road. It's also been elevated. You can see on the side that this is the level at which the original road was, and this is the new elevated road. Oddly enough, this roadway was still elevated from what the sea level was at the coast. And it said that this roadway served as sort of an embankment. And that's where the floodwaters that came in on Sendai, that big picture I showed at the beginning, that's where the water stopped, at this road. To see it a little better. So the green area is where the coastal forest is. This red area, red line, is that first elevated road. Those black triangles are the elevated evacuation structures. And then this black line is at Sendai Tobu Road. So the floodwaters came from here from the ocean all the way into this area. So that's how far the tsunami run-up was in that area in Sendai. So for reconstruction, so there's been many schools of thought, and each municipality or each city has their own method in which they are rebuilding. Some are doing like Sendai, where they're doing multiple obstructions. They're doing elevated roads. They're doing coastal forests, coastal embankments, evacuation shelters. Some are just doing really big seawalls and moving the residential community up into the hillside. This is Kesanuma. It's in Miyagi Prefecture, which is, again, the most heavily affected prefecture. In Kesanuma, so this is me standing by a building that is right across the port side of Kesanuma. So this wall is basically across the street from me. But this building that I'm standing at, can you guys see that blue placard? That's where the floodwaters was in that area. So this seawall, which is right across the street from where I'm standing, is 11 meters tall. So for Kesanuma, they decided, because they're a fishery community, they decided to build a massive seawall as opposed to elevating the ground surface. This is Ishinomaki. They also decided to do a massive seawall. And these bags here are recycled concrete, and that's what they're using for the fill inside of that seawall. The shape of this seawall is different from the shape of the other seawall. The design is dependent on the engineers and contractors within the municipality. So along the coast, the reconstruction, let me back up. The reconstruction for this project or this disaster is 250 meters of coastline has to be reconstructed or rebuilt. Each city or municipality decides on what their seawall or what their mitigation measure will look like. So you'll see when you go to different areas as you go north along the coast that you may see a different seawall as opposed to what you saw in the previous city. You may see the ground levels being elevated as opposed to having a massive seawall. And that's what I saw while there. This is an embankment, and this embankment I believe is 8 meters, and this is the one in Sendai. This is the one I was standing on. This is where that coastal forest is. And you can see some vegetative debris is still there. But the seawall has been reconstructed and improved. I believe the seawall in this area before the disaster was 3 meters, but now it's 8 meters. This is another area. This is Onagawa in Miyagi Prefecture. You can see the beginning stages of their seawall. There's some recycled concrete here. And these black bags is also recycled materials. In Onagawa, they have decided to do both seawall and then ground surface elevation. This is also Onagawa, and you see a little closer that they have these recycled concrete bags, and that's what they're using in the fill of the seawall. Minami Sanriku is a little further north, but it's still in Miyagi Prefecture. In Minami Sanriku, they have decided to basically elevate the whole city. This whole city, the ground surface has been raised 8 meters. So my tour guide and interpreter during this area, when I was visiting this area, he was like, my mother's house is 8 meters underground. And this is that emergency management building that I showed in the beginning of my PowerPoint presentation. So in this area, it's basically like they're still rebuilding the whole city. And this picture was taken this summer. How many years ago did the disaster happen? 6 years ago. Have they gotten that far with reconstruction? They haven't. Why do you think?
Well, are we talking about this specific place?
This specific place, but you'll see some other ones too.
Oh, 'cause I was going to say that they're not just doing a preventive method of like an embankment or something like that. They're trying to elevate the whole city. So
if they're raising the whole city by 8 meters, they need to get that filled from somewhere. There wasn't enough recycled materials to get it just from the debris. So they're also querying mountains to get some of that filled material. So it's taking so long. But another reason why it's taking so long is because the Olympics is going to be in Japan in 2020. And so they are rebuilding and building Olympic stadiums in Tokyo. And so most of the manpower that will be rebuilt in this area, because this happened 6 years ago, right? So it's no longer in the news. But what's important, what's in the news is the Olympic is coming in 2 years. So that's where a lot of the manpower is going. So the reconstruction in many of these areas is kind of stagnant. This is more of that same city. Oh, one thing to note, in this particular city, the ocean is here, or the bay, Sanriku Bay is here. This river, when the tsunami came in, the water came into that river, and it overflowed on both sides. So I mean, that's why it damaged the whole city, because the river overflowed. And so in areas like Minami Sanriku and also Otsuchi, I'll show you a picture of Otsuchi, they had similar issues where they had the rivers, the tsunami floodwaters came into a narrow waterway. And if you have something that's moving fast, and then you confine it into a narrow pathway, what happens? Does it speed up or does it slow down? It speeds up, so it becomes more destructive. So that's what happened here in this city. This is more disaster debris being used for seawalls. This is Kamaishi. This is another part of Kamaishi. You'll see that the shape of the seawall is a little bit different from the ones that we saw previously, right? Also in Kamaishi, part of their seawall reconstruction, they decided to do something different. They were thinking about the people in the area, because these are massive walls. I think this one is 11 meters tall. So for people that live along the waterway, this is fishery communities. Their livelihood is the waterways, right? So if you're used to seeing the water, and now they build massive seawalls, what do?
You leave it open for the fish, right?
Well, yeah, there's opening for you to drive down, but it's not an open waterway anymore. So you can't like live on the waterway. There's no beachfront communities now for this. But what Kamaishi decided to do is they decided to put windows on parts of the wall. So you can see it. And this is actually right across the street from my hotel, but you can see the port. Yes, sir.
So, would you happen to know, like, was there anything special about those windows to keep it structurally sustainable?
Yeah, so these are triple pane windows, but they are impact resistant.
Okay.
So, yeah, because with tsunami, you have to worry about waterborne debris and them becoming projectiles. So that's what happened to a lot of the things that were destroyed, because the floodwaters were lifting houses and buildings, and then those become bombs to other structures that they're running into. Hand raised.
Who decided like on these? I've seen like 3 different types of walls. So like, why the difference?
The difference is there are different municipality governments. They have different resources in terms of contractors, and then also the university community, academic communities are also advising them. So it's basically, in construction, is a bid game, right? So whoever bids the best and has the best solution, that's what the community will go with. So it's a big game. Yes, sir.
My name is Devin Addison Turner. I attend Prairie View University, junior. And my question to you is, how does that affect the economy with the construction and the reconstruction that's going on? You have to elevate the city while everyone has jobs or working and have goods that are being transported. Like, does that affect the currency that's going on? Does that affect like the infrastructure at all?
Okay, so thank you for your question. It does affect, but for Japan, like their governmental workings is different from us. So the national government basically gave these cities money to do things with. So it's different from here, and we get federal assistance as local residents. The national government gives money to the local government, and they say you're going to use this money for rebuilding. I'm sorry?
It's a grant.
It's basically a grant, yes. But it's given to the governmental officials to do what they need to do for the city or the municipality. So that there is an effect on the community because it's taken so long to rebuild. That's one thing. Because it's taken so long, this disaster happened 6 years ago. So because it's taken so long to rebuild, people have reestablished other places. So that means they've lost employees. They've lost income coming into that area. So it does have an effect, but the amount of the effect, I don't know. Sorry, economy is not my focus, but if you're really interested, I can get that information for you.
All right, thank you.
This is Otsuchi. This is another area, but this is north. So this is now in Iwate Prefecture. This is Otsuchi Bay. And this picture was taken this summer. There is one local business here and one house. In Otsuchi, only 1/3 of the population has come back or plans to come back. So basically, in a lot of these areas that are rebuilding, they're rebuilding ghost towns because the residents have now reestablished themselves. So if you were a child and you were born when the disaster happened, you're basically a first grader now. So your parents aren't going to want to move you back to where you used to live because, you've already reestablished yourself in this new community. So that's what I saw in a lot of these areas that they're rebuilding. So in Otsuchi, they're also building massive embankments and seawalls, but in terms of the residents, they own land, but no one's coming back. This is Mayaku. So in addition to using debris to assist with the reconstruction of coastal embankments and seawalls, they're also reusing debris for memorial parks. So this is a river gate or water gate here, a newly constructed water gate. This picture shows components of the damaged or previous water gate. They basically have set it aside to make a memorial park. So in several areas, they're also recycling, reusing debris from memorial parks. This is Taro. This is also up north in Japan, in Iwate Prefecture. The importance of this picture is that this is the seawall. You see they have rehabilitated, this was the existing seawall. They have rehabilitated that seawall, but they have moved the coastal community all the way up in the hillside. And this is almost to the tip of the Hongo Island of Japan, right before you get to Hokkaido. This is Kuji. In Kuji, this is a river gate, and this placard, like on that building, shows where the water was. The river gate is here. The water came up here. So the tsunami floodwaters flooded over the river gate. But luckily in this area, the city is offset. So right behind this river gate is a coastal forest. So although the tsunami floodwaters came over the river gate, the coastal forest slowed down the tsunami floodwaters. So in Kuji, that city, they said that the water level came up to, I think, their calves, their legs. So it wasn't as high as some of the other areas. This is also in Kuji, a closer look at another part of the city, and see the floodwater wasn't as high. So during my time there in Japan, I've been learning about how they're rebuilding, how they're recycling, reusing debris for reconstruction, and what technologies they're coming up to recycle and reuse debris for the reconstruction. So just to summarize what I'm doing in my Fulbright, I'm learning about what's happening in these two affected prefectures, both Miyagi and Iwate. Again, I still haven't seen Fukushima. There's still some issues going on with contamination, and it's restricted to go to certain areas. But the two areas that I have been studying so far, they have successfully managed their debris. They're recycling and reusing both concrete and tsunami deposits for the reestablishment and reconstruction of their cities. And also, they're coming up with new technologies in which to recycle and reuse debris. Some are using the concrete debris in bags and filling it into their seawalls. Some are using it in coastal embankments. For some of the memorial parks, they have mixed debris that they are compacting and using that as coastal embankment areas or coastal forests. So these are lessons that we can learn from what you do with overwhelming amounts of debris, and then we can compare that with what we're doing here or what we have done with disasters here. This past summer, as I said, hopefully some of you can join me in this work. Thanks to the support of the National Science Foundation, I was able to take 8 students with me to Japan for 1 week. We basically toured all of these cities, and my students got to see what it is I'm studying. Actually 7 students and 1 high school teacher, but she's applying to grad school, so I'm trying to bring her in as a graduate student. But this was a summer reconnaissance experience so that students, both undergraduates and beginning master's students, can learn about what I'm doing in disaster mitigation and disaster recovery research, in the hopes of encouraging them to consider this as a field of study or a career field. So I'd like to thank all those that have had a hand in me learning this information, and acknowledge those that have been helpful in me collecting the data while there in Japan. But before I completely end, that's the end, but it's not the end. Can you guys tell who this is? Does it look like me? So that's me. I went to Kyoto and got this done. But I want to tell you guys one last thing before I end about the SURGE project, which is a newly funded NSF project that will allow me and my colleagues to include graduate students in our research. The goals of this is to increase the number of minority graduate students in STEM that are doing disaster mitigation research. We have a Twitter page and a Facebook. If you're interested in learning more about how you can be involved in this research, please check out our Facebook or our Twitter page. And I think I will stop there and answer questions. I just have miscellaneous pictures at the end.